Hello, everybody. My name is Henry Ferris. This is my demo of the Project 4 for networking for multiplayer games. That, of course, being lag compensation for the previously built Fruit Ninjas game. Um, as per usual, up first will be the code review. Um, and our first talking point here is latency simulation. Oh, and once again, I'm just going to focus on the new stuff. So we did have to simulate latency such that we could effectively test instances of said latency. Um, in terms of, I did want to briefly show how that was managed. We did have config files in which lagsim ticks, keep in mind it's controlled in terms of ticks, can be manually configured. It's worth mentioning that this can be configured to be server or client side. So there's the build folders for each, and both of them have their own config, and you can set a delay for each. It could be the same, it could be totally different. Either works. In terms of looking at the actual code, I did want to go into Network Manager and show line 264. Here we go. So send. This is in particular our delayed ping. The important note here is that we simulate lag by scheduling outbound packets for future game ticks as opposed to just sleeping and waiting. Um, the important factor here, of course, is that sleeping is blocking, which isn't really acceptable in this context because it creates its own issues like stuttering or perceived latency, etc. Next talking point is that ping is a full round trip. Sorry, I just need to get my notes up proper here. Um, Ping is a full round trip. We can view that in server on line 189. Yeah, so message type ping. Um, we'll pass this out to the server. The client sends ping ticks. The server immediately echoes said message, and then the client will update the measured ping on reception of that echo message. Moving into sword prediction, which was our first method of lag compensation. Let me just get to client. Nope, as it is client side. And so that is going to be in client. Here we are. Online 281. Oh, nope, sorry, 201. There we are. Yeah. So handle mouse. So with prediction enabled, the local sword moves immediately on mouse input. We're not waiting necessarily for any validation um, from the server. Um, it's but when significant error is detected, it's then manually corrected and accounted for. Final talking point here is fruit lag compensation. This is also client, and I can just go right on down to 308. Looking at our latency compensation, it's arrived. When fruit is created from the sync step, of course, we only send that initial fruit creation. We extrapolate it forward by measuring latency ticks to better match the server status. Um, yeah, so now I will go into a brief demo. Get both of these up. Of course, we need to launch the um, server first. Oh, although I am going to, for at least the initial one, I'm going to disable uh, simulated lag. Just got to configure that really quick. 0. Save that out of here. All right, so boot up the server. You can connect to distinct IPs, of course, separate, as was tested earlier. Right now, the demo is just going to be on one device. So we get both of these windows up and connected. As you can see, nothing. Oh, I did get a basic UI setup. for toggling our compensation methods, again for easy testing there. You'll notice 33-ish is our min ping. This is because with about 30 ticks a second, 33 milliseconds is the corresponding period to that frequency. So that's the lowest ping you can have. And because of how we have it implemented without blocking, ping can only be in increments of about 33 because it is per tick. Now there is some, or at least the simulated, there is additional stuff going on there in terms of actual connection, like when we tested with clients on distinct devices. But up first, I'm just going to show basic no simulated lag. This is what it should look like. Volume on a little bit. So you guys have seen this before. So I'm going to get this closed down. We're going to put some lag back in. Control S to save a bit of time. So we're now stopping, or we're now delaying 2 ticks either way, half on client, half on server, for a total of 4 ticks. 4 times 33, or 5 really, puts us at about 162. So when we get both our server and our clients up, and of course connected, see some here, although it's accounted for. We do start to run by default, so I'm just going to turn these off for this demo, and here you can really see the delay. I mean, this is representative of the actual data that's coming through. Go ahead and get us started so you can see how this performs in game. Notice that stuff seems to come through on the other side, right? Because of course you can understand now something's wrong. It is quite a way behind. So we go in here, turn our sword back on. It looks like it's synced. It works. Now in completion, you see a lot of performance difference. I'll turn that on. A little faster, you'll notice there's a bit of delay there between the cut. Performance. I think it's that's it. If we're purely looking at it on does do it, and yeah, that's the functional demo. Thank you very much for your time, and have a good one. Bye bye.